$14,999. Tesla just confirmed a price that breaks every industry prediction. The Model 2 was supposed to cost $30,000. Musk slashed it by half. The reason? Aluminum-ion batteries. Internal leaks reveal Tesla's ditching lithium for chemistry that delivers 500 watt-hours per kilogram energy density. Double today's cells. With a 53 kilowatt-hour pack, the Model 2 hits 300 miles of range, while cutting $2,000 per battery. BYD's selling EVs at $12,000 in China, and Tesla's fighting back with tech that could rewrite battery economics. December launch confirmed. Can aluminum ion really scale to mass production? The data suggests yes. Let's start with the reality that forced Musk's hand. BYD outsold Tesla in 2024, and their entry-level EV cost $12,000 in China. Tesla's cheapest option, the Model 3, starts at $38,990 in the US. That's more than 3 times the price. Even with subsidies, Tesla was losing the affordability battle, and Musk knew it. The original Model 2 was planned at $30,000, a price that seemed competitive when development started. But by 2025, that number looked increasingly inadequate. Chinese manufacturers weren't just undercutting on price. They were proving you could build functional EVs at radically lower costs. Internal reports from Giga-Texas reveal that Musk gave his teams a stark ultimatum. Find a way to cut the price in half, or the project doesn't move forward. That directive led Tesla's engineers to a conclusion that seemed impossible at first. You can't get to $14,999 by tweaking existing technology. You need a fundamental breakthrough, and that breakthrough came from an unexpected direction, completely eliminating lithium from the battery. Every Tesla ever produced has used lithium-based chemistry, NCA for performance models, NMC for balanced applications, LFP for budget vehicles. All variations of the same core element, but lithium has become a problem. In 2022, lithium carbonate prices hit $80,000 per ton. By 2023, they crashed to $15,000, then rebounded again. Musk publicly criticized this volatility multiple times, calling it unsustainable for mass-market vehicles. The solution wasn't finding cheaper lithium sources, it was abandoning lithium entirely. Tesla's battery division started investigating aluminum-ion chemistry, a technology that's existed in laboratories for decades but never reached commercial production. The fundamental advantage of aluminum comes down to basic chemistry. Lithium ions carry a single positive charge, while aluminum ions carry 3. That means each aluminum ion can transport 3 times the electrical charge per particle, enabling faster energy transfer and higher current flow. Current lithium-ion cells in Tesla vehicles average about 250 watt-hours per kilogram of energy density. Early aluminum-ion prototypes are hitting 500 watt-hours per kilogram in controlled testing. That's double the energy storage at the same weight. For a compact vehicle like the Model 2, this creates extraordinary efficiency advantages. Less battery weight improves handling, extends range, and reduces overall vehicle cost. The economic case for aluminum is even more compelling than the performance metrics. Aluminum comprises 8.2% of Earth's crust, while lithium accounts for just 0.006% to 0.009%. That thousand-fold difference in abundance translates directly to price stability and supply security. No single country controls aluminum markets the way they can control lithium supplies. The leaked specifications indicate Tesla's aluminum-ion pack will be 53 kilowatt-hours. That's smaller than the Model 3's base 60 kilowatt-hour battery, yet the Model 2 is projected to achieve 300 miles of range. The efficiency comes from combining the superior energy density of aluminum-ion chemistry with the Model 2's lightweight construction and optimized aerodynamics. Cost analysis reveals the magnitude of this shift. A 53 kilowatt-hour LFP battery currently costs approximately $5,300 at standard rates of $100 per kilowatt-hour. Tesla's aluminum-ion pack is estimated at $3,300, a $2,000 reduction per vehicle. Scale that across projected production of 1 million units annually, and you're looking at $2 billion in cost savings. That's the financial mechanism enabling the $14,999 price point. This brings us to how Tesla is rethinking vehicle design to support that aggressive pricing. The Model 2 represents a complete departure from Tesla's existing design language. The front end eliminates the premium light bar featured on the Model Y and Cybercab. Instead, the headlights sit higher and deliver sharper, cleaner lines that create a more youthful expression without appearing cheap or stripped down. The body construction uses Tesla's next-generation Giga-Casting process, where large vehicle sections are formed as single aluminum pieces, rather than assembled from dozens of stamped parts. This reduces manufacturing complexity, eliminates panel gaps, and creates an exterior that looks seamlessly integrated rather than budget-constrained. The intentionally simplified curves serve dual purposes, lowering production costs while optimizing aerodynamic performance for maximum efficiency. Tesla made a strategic decision on the door system that reveals their priorities. No Falcon wing doors, no elaborate mechanisms. The Model 2 uses conventional four-door architecture with refined hinges and optimized opening angles. The Model X taught Tesla that mechanical complexity doesn't scale for mass-market vehicles. Simplicity wins when you're targeting volume production and minimizing maintenance issues. Inside the cabin, Tesla made cuts that will disappoint some buyers but were necessary to hit the price target. Fabric seats replace vegan leather. Seat heating is eliminated. The panoramic glass roof is gone, replaced with a standard metal roof. Single-layer acoustic glass reduces sound insulation compared to premium models. Ambient lighting uses single-color LEDs, and the audio system features fewer speakers. However, Tesla preserved the complete self-driving hardware suite. The front-facing camera is integrated into the fascia, full processing capability remains on board, and over-the-air update infrastructure is unchanged. This isn't negotiable for Tesla's long-term strategy. The Model 2 is designed to eventually operate as part of Tesla's autonomous robotaxi fleet, generating ongoing revenue beyond the initial vehicle sale. Understanding why these choices matter requires looking at the competitive pressure Tesla faces. BYD didn't just beat Tesla on price in 2024, they demonstrated a manufacturing model that's extremely difficult to counter. Chinese automakers benefit from lower labor costs, government subsidies for EV production, and vertically integrated supply chains. BYD manufactures its own batteries, semiconductors, and even the mining equipment for raw material extraction. That level of integration creates cost advantages that can't be easily replicated outside China. Tesla's defensive moat comes from software and artificial intelligence infrastructure. The full self-driving system has been trained on billions of miles of real-world driving data collected from Tesla's vehicle fleet. That data set creates advantages in autonomous capability that Chinese competitors can't quickly duplicate. Hardware can be reverse engineered and manufactured. Training data accumulated over a decade cannot. The Model 2 represents Musk's strategic counterattack. If Tesla can't match Chinese manufacturing costs directly, they can compete through technological advantages that are harder to copy. Aluminum-ion batteries could provide a 3 to 5 year lead before competitors successfully reverse engineer and scale the chemistry. That window might be sufficient to reset market dynamics and reestablish Tesla's competitive position. The challenge nobody's adequately addressing is whether aluminum-ion can actually scale to mass production. Lithium-ion technology took decades to commercialize after initial laboratory development. Aluminum-ion remains largely experimental, with significant unsolved problems in electrolyte stability, electrodegradation, and cycle life performance. Reports from Giga, Texas suggest Tesla has been running pilot production lines for aluminum-ion cells since late 2024, indicating they're further along than most industry observers realize. But pilot production and million-unit annual production are fundamentally different challenges. Battery chemistry isn't software that can be patched after release. Physical limitations create hard constraints. One thermal stability issue, one batch quality problem, one safety incident could derail the entire Model 2 program. The December launch timeline suggests Tesla believes they've solved the critical technical problems. The uncertainty is whether those solutions will hold up under real-world conditions at production scale. Meanwhile, Tesla is simultaneously pushing Optimus, their humanoid robot program. Musk announced a $20,000 target price and claims Optimus will be more significant than any vehicle Tesla produces. The logic makes sense when you consider market sizes. The global automotive industry is worth approximately $3 trillion annually. The global labor market exceeds $90 trillion. If humanoid robots can perform even a fraction of human labor tasks, the addressable market dwarfs the automotive sector. Tesla's robotics advantage stems from their vehicle development experience. Optimus uses the same AI processing chips, camera systems, and neural network architectures as Tesla cars. The actuators are automotive-grade components designed for high-volume manufacturing. This isn't academic research. It's an industrial product built using proven production techniques. XPeng, the Chinese electric vehicle manufacturer, just revealed their own humanoid robot with a rumored $10,000 price target, half of Tesla's projection. The hardware isn't the difficult part. Building mechanical systems that move like humans is achievable with current technology. The challenge is artificial intelligence capable of operating effectively in unstructured, unpredictable environments. Tesla spent a decade and billions of dollars developing full self-driving capability. XPeng would need to compress that development timeline dramatically to deliver competitive, autonomous functionality. The legitimate question is whether Tesla is overextending itself. Aluminum-ion batteries, sub-$15,000 electric vehicles, humanoid robots, autonomous robotaxis. Each initiative could consume an entire company's engineering resources and management attention. Tesla is pursuing all of them concurrently. This strategy either validates Musk as an extraordinary industrial orchestrator, or it exposes Tesla to execution risks that will overwhelm the organization's capacity. The Model 2 unveiling is scheduled for December 2025. Musk told Joe Rogan he couldn't discuss details before the official reveal, but suggested it might be the most memorable product unveil ever. Those are significant words from someone who's live-streamed rocket launches and unveiled tunneling systems. If Tesla executes successfully, if aluminum-ion chemistry works at scale, if manufacturing ramps smoothly, if the $14,999 price holds, the entire automotive industry faces fundamental disruption. Legacy manufacturers already struggle with EV profitability. A sub-$15,000 Tesla would make internal combustion vehicles economically obsolete in many global markets almost immediately. The alternative scenario is equally consequential. Any significant failure, battery performance issues, production delays, quality problems would damage Tesla's credibility severely. Musk has a documented history of optimistic timelines. Full self-driving next year has been repeated annually since 2016. Cybertruck launched years behind schedule. Semi-production remains minimal. Tesla's execution track record creates reasonable skepticism about December delivery. The aluminum-ion decision is binary. It's either a breakthrough that redefines the industry, or it's premature deployment of technology that isn't ready for commercial scale. Battery experts remain divided. Some characterize it as transformational innovation. Others warn that viable commercial production is still years away from reality. Here's the reality. Tesla's $14,999 Model 2 with aluminum-ion batteries is a technological counterstrike against Chinese dominance. If this works, global battery costs drop 30 to 40% within 3 years, making EVs affordable worldwide. The real battle starts after December. Every automaker will copy aluminum-ion chemistry. Tesla's betting on a 3-year lead. That window decides everything. If aluminum-ion scales, it powers Model 2 and Optimus robots. Tesla becomes an automation platform, not just cars. We're watching a trillion-dollar robotics industry form. What happens first? 1 million Model 2 sales or competitors launch aluminum-ion? Comment your prediction. If this clarified Tesla's strategy, hit that like button. Subscribe to Tesla Zone for deep analysis beyond headlines. Turn on notifications for our full Model 2 breakdown in December. The $15,000 EV era starts now. Adapt or disappear. This is Tesla Zone. See you next time.